Good afternoon, everyone. I'm Dr. Ritesh Palkar, working as Assistant Professor in Department of Chemical Engineering, Faculty of Technology, Marwadi University. Welcome you all on this second webinar, which we are conducting on process intensification in chemical industries. I know there are many participants, those who are joined to us. They are from different backgrounds apart from chemical engineering. But here we are planned to discuss about basics and somewhat principal applications of process intensification. So I welcome my co-host, Dr. Manish Khodwe. He is working as associate professor in our Department of Chemical Engineering. He is having 20 plus years of experience in academics as well as in industry. So today we are going to discuss about process intensification in chemical industries. Okay, so let us start. In meanwhile, if some students, those who will come in between, we'll try to accommodate them in between. Okay, so we'll start with this. Manish sir, am I audible?
Yes, sir. Yes, sir.
Yeah. So we'll start with the outline of today's discussion. So today we are going to discuss about the second slide, please. Yeah, today we are going to discuss, we'll start with in general, what is chemical process, how the changes are occurring inside the system, that we are going to discuss as a preamble of this today's talk. Second, very important, what is process intensification? Okay, what are the pro and cons of present systems, and how the process intensification has come into picture in today's life. Next, what are the principles and advantages? Apart from that, there are different kind of let's say theories are available for process intensification. So for this, we will try to discuss different kind of principles as a part of basic discussion, basic study, and what are its advantages simultaneously. As a chemical engineer, we have to deal with different kind of design parameters. So the fourth point which we are going to discuss today is about what are the design considerations when you guys will go for process intensification, right? Next, as we will discuss first point as chemical process. So how to do the integration of all these processes will be discussed by me and Dr. Manish Khodwe. And if we are discussing about the process intensification and how to do the integration, so what will be its component? That is also an important discussion which is to be highlighted, I feel, in due course of time. Okay, so at the end we'll try to show you some kind of examples which mostly referred as one of the reference basis for process intensification. Okay, so as you may aware about that, process intensification has recently started in 1990s. There in one of the conference, this topic was first discussed by Ramshaw, and he has given different kind of definitions. Okay, so according to that, this is our outline, and our aim is by the end of this webinar, our participants will be able to know about what is process intensification. Participants will be able to identify the process or processes. They will be able to apply the different process intensification techniques and identify and discuss or design the process integration, process integration along with intensification. Okay, so this is the outline of our today's talk. Next topic is chemical process, which will be discussed by Professor Manish.
Good afternoon, everybody. Everybody know about the chemical industry. Normally, there are three steps. When you are learning this CRE, chemical reaction engineering, there also, these are the three steps normally we studied, we learned. So the raw material, this is the first step, normally we required for the processing. And the major part is process, whether it is physical or chemical or biological process. And we are focusing on this process. And finally, after this process, we get the product, which is marketable, means our aim is always to make the marketable product, competitive product. So on that basis, keeping in that mind, we have to do the process which our basic chemical engineering role is there. We focus on the chemical process, means cost is very, very important. Ultimate aim is the production cost, because the lot of products will be available in the market and we should be competitive. So where we can do the competition? So the major is raw material, but most of the time the cost of raw material will be fixed, and that there is some limitations for the cost of raw material. So ultimately, so we are talking about the chemical process modification. The pressure, temperature, and process calculation, stoichiometric ratio, and all those things, we are optimizing in the pilot scale, that is commercial scale. And then we do the scale up. Scale up means it will be the reaction we are taking in the tons together or more than that. So normally three steps we are doing in the any industries, and keeping in mind the economic, safety, and sustainability. Sustainability means again we are focused on the cost competitive. So when we do the modification or the intensification of any process, we have to focus on the majorly the last stage, that's a some do the modification in the that process in the units, and we say it is intensification. So major objectives of the intensification is the process. In the process modification, we want to do the process in that unit as small as possible, because you know that when we are limit tends to 0, or when we are reducing the size, automatically the energy problem or the environment problem or the handling problem, everything will be reduced, and automatically the efficiency, automatically it will be connected to the that smaller process as well. And definitely when we are reducing the size, we get the cleaner production also. So cleaner production, efficient production, and safer. So safety automatically it will come under that. So major is we have to focus, we have to reduce the size of that equipment by some modification, and we calling as a intensification. So if I want to give one small example, the settling tank, uh, which is coming in the environment or effluent treatment plant. So if you do the settling by gravity with the help of using the gravitational force, it takes a lot of time. It takes own time for the settling. But if we use the centrifuge force, if we use the centrifuge, we can do the same settling within a short time. And this is the small example of the intensification process. So these are the small modification we have to do in each equipment. So ultimately, all process when we combine, we can say it is the intensified full process. Sir,
Yeah, definitely,
Ritesh sir?
definitely. Yeah, process intensification, as suggested by Dr. Manish, it is a kind of thing where you can improvise your process by considering those four parameters, and at the end, safety is at most of importance. Okay, so it may come across maybe along the processes which we are discussing from, let's say, starting of industrial revolution. So when you will go through the different literature, you will be able to find out the various examples based on how these came into picture, process intensification. So one of the best example which we have, which already referred, it is from a 16th century technology for gold production, or gold production from ores. If you are able to see this picture which we have kept in our slide, in our on your screen, there are different kind of reactors, stir tanks, stirs, right? And how these are working, you can see. So this is the technology which is used in the 16th century. See, as you might have seen, there are different kind of you have studied about how the propellers are working, what are its shapes, sizes, what are the reactors, what is CSTR, how they are connected in series or parallel. So different kind of things you can see from this picture, right? So these are taken from one of the literature where he demonstrated the let's say woodcut technology to perform in gold mines for the production of gold from the ores, right? So this is just for example that what we are started with. So you please do remember this is the technology from 16th century. So just to go to the next part which we are going to discuss, it is about next slide, sir. Yeah, next we have to discuss about its, if I'm not wrong, different processes, how it is to be worked or how it is to be done. Yeah, previous one, sir. Previous.
Yes, this one only.
Yeah.
This.
So what we have gained due to the process intensification? Yes, these are the very important points which we have to discuss. One should how to improve its energy requirements, right? And process efficiency. As discussed by Dr. Manish earlier, what we want in a process, you want minimum resources, minimum raw material to convert that raw material into desired marketable product. So as you are aware, it can be done with the help of different kind of machineries, different kind of reactors. So everyone knows that energy is one of the important parameters that has to be taken care. So what is this? If that Ramshaw has given this definition, different definition he has given. One of the definition, in one of the definition he has discussed about there will be a dramatic change in the system or dramatic change in the process. So how it is to be done? It is to be carried out with the help of its energy content and efficiency. So ultimately, if the amount of energy required for any processing is to be reduced up to a certain extent, then anyhow that efficiency of the process, either it may be chemical process or mechanical process, it is going to be increased, and that is what our aim is. Okay, so it is one of the important parameter which we have to discuss, and this is what we want as a part of this webinar. What you guys want to share the knowledge, your knowledge after end of this webinar is what we have gained through this process intensification. Okay, next one, sir. Yeah. uh, Dr. Manish, do you want to discuss something
Yes,
about
sir.
this?
No, no, continue, sir. Continue.
Yeah. Okay, fine. So in the last slide, when we are discussing what we are looking for minimization of energy, or let's say process efficiency should be increased in a such a way that we have to maintain the safety features, as well as we should not hamper the features of environment. Okay, so let's say this is a cycle. If you want minimum energy and maximum process efficiency, it must go through the different environmental parameters which we have to take care, and safety is also very important. So this is let's say this is the four quadrant of any process, and that has to be taken care when you will start your process, right? So as Dr. Manish has already explained how to do the process intensification, either you can enhance the heat and mass transfer properties of any process depending upon the nature of the system, right? Sometimes it is also said that when you are having less resident time, it varies, again it varies depending upon your requirement. So you can have the enhancement its properties in terms of heat mass momentum transfer, right? Other than that, if you are aware about the driving forces, those are required. Let's say in mass transfer it is concentration gradient, heat transfer it is, let's say, heat transfer. Okay, so there are different types of gradients. So enhanced driving force also leads to reduce the resistance offered to the system, right? Apart from this, we can combine the different units. If you can remember the last image which I have shared with you from 16th century, you might have seen the different kind of stir tanks, stirs. Those are connected to each other. You might have seen that, you might have heard about, or you might have thought about, what if I can merge those, let's say, reactors, pumps, and so many other things along with those required let's say parameters. So it is another parameter, let's say combination of unit operations, right? And apart from this, new study has revealed that when we will go for external force field, there are different kind of external force field which may increase or decrease, let's say, the rate of reaction, let's say very specific to the chemical reaction. And in many systems it required actually, either we may have to increase, or either we may have to decrease, or we may have to keep constant some parameters throughout the your processing, right? So external force field, let's say one of the technique is external influence, let's say in terms of ultrasonic. Okay, so this is one of the important thing which can be captured in nowadays in most of the industries, that is implementation of external force field. So overall idea is, if we have to deal with process intensification, we have to deal with four important parameters. The first one is energy, second one is environmental aspect, third one is process efficiency, and the fourth one is atmos safety of, let's say, industry as well as of environment and surrounding. Okay, so this is what the idea behind this slide is. Yeah. Yeah, Dr. Manish, do you want to highlight this point?
Yeah, sir, Ritesh sir, when we are talking about environment, external force field, now you can see that when force other than gravity, when we use centrifugal force, as I told you, the settling tank example, rather than the gravity force, if we apply centrifugal force, then there is an advantage of fast settling. The same way, if we apply the centrifugal force in the what is called that separator, dust separator, and there you can see the settling of the heavy material will be the rate of the settling will be faster than the gravity separation. So we can use this type of external forces to modify the process or to get the intensification. For example, if we apply the, but there is no limit about the force which you can apply. So in that way, as you do the changes or if you apply the centrifugal force or any other forces, the ultimate aim is to increase the heat and mass transfer rate. And once if you are able to increase the heat and mass transfer rate, you are achieving the efficiency, you are achieving the uh, this safety aspect parallelly, and definitely you will get the advantage and you can reduce the size. Major important is once the rate of heat is increased or rate of mass transfer is increased, the same capacity which you are utilizing that unit you can reduce the size for the same capacity, and automatically your the safety aspect will be improved, as well as the reduction in the residence time. This is very, very important. So when we, if you are able to increase the rate of heat transfer and mass transfer, definitely your uh, how you are increasing the intensification, the same way if you are able to reduce the residence time, means the rate of reaction if you are able to increase, definitely the residence time you can reduce, and in that way also it is possible to lead the reduce the physical size or plant itself. So major aim is to reduce the size of the equipment by applying different techniques, right? Ritesh sir, Ritesh sir.
Sorry, there was some problem. Yeah, as suggested by Dr. Manish, that we have to deal with the different kind of forces, as he suggested in terms of the example of settling tank, then the force which it is required in general, it is let's say gravity. But other than gravity, which kind of forces you can apply on the system, and how to achieve the process parameters, required process parameters in terms of improved efficiency, that is discussed by Dr. Manish. Next, in general, you might have a question in your mind, what exactly this PI is, process intensification is, right? So it is nothing but it is a dramatic and drastic change in the process industry or in a process. So how it is to be done, or how that changes as has occurred in the system, so it depends on your methodology which you are going to acquire. So the first one, it may be based on the equipments on, and the second one, it is based on the which kind of methods you are using for your process. So let's say equipments, which kind of equipments you may have. If I will ask, if someone will ask you which kind of equipments you want as a chemical engineer, so definitely you guys, one of you will answer like that, yes, there will be some equipments where I can carry out chemical reactions. There are some reactions where I don't want to carry out my reactions, but at least there must be some change, as discussed by Dr. Manish. Because as the processes or chemical reaction systems or chemical systems are divided into, let's say, mechanical process and let's say physical process. So somewhere you just want to crush it, right? So sometimes there will be a chemical reaction, sometimes it won't be, right? So equipments may be divided as with and without chemical reactions. Which kind of methods you can use for PI? It may be multifunctional, right? At the same time, if you are carrying out different kind of operation in a single unit, in a single reactor, right? So that may, we can say that is a multifunctional. One can say I want to work on a hybrid methodologies. Which are those? Let's say you are having conventional methods, and if you are using some kind of membrane operations, right? So that I can say that is a hybrid operation. Okay. And there are so many methods which are nowadays we are using in order to intensify our process. So in general, process intensification, it broadly classified or broadly studied nowadays on the two aspects, that is based on equipment and methods. Okay. Next slide, sir. So just to move forward, Manish sir, next slide, please.
And advantages.
Yeah. So as we have discussed about, Manish sir, do you want to cover this part? Hello.
Okay, sir.
Yeah.
Hello.
Yes, sir.
Yeah.
Please
So
proceed.
major, yes, sir. So we want to see the principles and advantages of the intensifications. So we know the principles. So what are the miniaturization is the major important principle for this intensification. As I told you, the reduce the size of the equipment as low as possible so that the energy cost and the process cost related to energy, mass transfer and other things, automatically it will be reduced by miniaturization. And you can say it is the basic principle of the intensification. So automatically, with the help of miniaturization, you can reduce the capital cost, because capital cost, if you see uh, the total cost, if you calculate the cost of the industry, so major is the capital cost, because as the size of the unit is big, the cost of that unit will be more and more, and it cover the capital cost. So you can reduce the capital cost in that way. Then automatically the safety and energy efficiency, it will do the handling of the small unit and the handling of the big unit, safety aspect it covers automatically. So it will cover the safety and automatically energy efficiency. Energy requirement will be less in the small unit if you are able to maintain the same capacity in the small unit. Then you can focus on the product quality. You can monitor very nicely in the small size as compared to big size. So control, process control will be more, you can say it will be more controllable in the small capacity as compared to big one. So automatically product quality, it will be improved. Then next is process flexibility. Flexibility means what? When most of the industry, there will be the changeover of the products. It is not the thing that the only one product can be produced in the one plant. There are different categories. You can say it is a derivatives of the product. And whenever you are change over the products, you will have the flexibility. And when the size of the plant will be less, or the size of the equipment will be smaller, you will get the more flexibility in the process. And just in time manufacturing, and manufacturing time automatically, obviously it will be manageable or reduced. And capabilities and opportunity for the distributed manufacturing. What is mean by these capabilities and opportunity? You will have the more capability and you will have the more opportunity to increase the derivative of the product for distributed manufacturing. So these are the major advantages for this intensification process.
Yeah, definitely,
Ritesh
Manish
sir?
sir. Yeah, definitely. As you had discussed in the last slide, there should be flexibility, right? One important point
Right.
which has been highlighted by Dr. Manish is flexibility of your process along with your different kind of process parameters, right? So let's say there are different kind of parameters, process parameters along with its components. Okay, so let's say we'll go with a very basic unit operation systems, right? So uh, we know we want different kind of reactors. Those can be used for different processing units. So just for discussion, let's say we are having different kind of reactors like heat exchangers, distillation columns, separators, which already discussed by Dr. Manish. Okay, so if we will try to intensify those individual items in your process, your system is automatically intensified. Okay, so how to intensify all these things? As I had discussed earlier, that PI is divided into two sections. One, it is based on the methods, and second, it is based on your let's say parameters. Okay, or let's say equipments. So very important is you must have multifunctional models. Which are those models? You can have a combined heat and mass transfer functionality, or you can have heat and separation duty, on you can have heat, mass and momentum along with separation, right? Sometimes fluid may come into picture, sometimes purification may come into picture, sometimes your cost may come into picture. So there are large variety of parameters, those we need to consider as a process engineer. Okay, so these are the parameters which we have to discuss as essential and of let's say intensified. Okay, next slide, sir. Yeah, but what exactly it is? You might be in a dilemma that Dr. Manish and Dr. Ritesh, those are discussing about process intensification, and process intensification. But what exactly it is? What is its boundary? What are its limitations? What are its applications? Okay, so let us discuss in terms of let's say what it encompasses. Okay, what is it, what it encompasses. So let's say we today we want to discuss this in the form of not only and but also. So process intensification, it is not only the development of novel reactors, novel systems, okay, or more compact equipments. That is what Dr. Manish has already discussed, that compactness, right, or flexibility. But also it tries to provide you intensified methods which can use the different variety of techniques that has not been used as a single unit. So one of them is, let's say, ultrasound technique. The second one is radiation. Okay, just say the example which Dr. Manish has already emphasized on, let's say for the reactors. In some reactions you may require heat, or somewhere you may not require the heat. Sometimes heat may be generated inside the system when the reaction is going on. Sometimes you want to give heat to the system from the or to the process from the outside. So these are the things which we need to encompasses inside the system. Okay, so this is what all about the process intensification is. Okay, next slide, sir. So this is what we have to discuss about. That is, we want intrinsic safety and how it will increase the efficiency or energy efficiency. So though we are discussing about the scale up of plants along with different kind of reactors or unit operation and unit processes, it must be intensified along with the different benefits like safety and energy efficiency, which we are emphasizing, or which every inspecting body is emphasizing on nowadays, right? So it is very important that we have to add those inventories in a such a way that which will reduce the hazards, right? So either it may be unit operation or unit process, we have to deal with the parameters where we can reduce the hazards. Either it may be in terms of any kind of hazards which we can discuss in terms of SHE, right? Yeah, next one, sir. Yeah, these are the advantages. As Dr. Manish has started with, let's say, a very simple example which we as a beginner can emphasize on. So what is the advantage? There are different processes which has to be carried out in batch mode or either it is in continuous mode. So can we alter the situation? Can we increase our production? Can we reduce our inflow? Can we decrease some kind of, uh, let's say, intrinsic parameters, right? So this is what one of the parameter the process engineer may look after, that there may be interconversion between the process parameters. So first one, let's say we can change or we can switch to the batch, we can switch to the continuous process, right? So what it can facilitate, it may have more efficient system either way, and it minimizes the hazard. Okay, so this is what we want to emphasize as a part of discussion in process intensification, that we have to increase the efficiency, but at the same time we have to reduce the hazard. It may be of any kind. Okay, yeah. Next one, sir.
Sir, I would like to highlight this. I want to
Yes,
give
sir.
share some more information about this.
Yes, sir.
How to convert the batch process into continuous reactor and how we get benefit with respect to the exothermic reaction as well as safety
Mhm.
aspect.
Yeah, yeah.
So in my last, when I was working in industry, we used to do epoxidation reaction in batch. So definitely it was the highly exothermic reaction,
Mm-hmm.
and that exothermic reaction they want to convert into the continuous mode. And we took
Okay.
the small packed bed reactor,
Huh?
and in that continuous packed bed reactor, when we succeed the conversion of batch to continuous, that exothermicity we would control very easily, because the small amount of reaction taking place continuously and we are continuously controlling the exothermicity, as well
Mm-hmm.
as it is the highly explosive reactions, because
Yeah.
they are using the peracetic acid, and
Mm-hmm.
peracetic acid is more dangerous than the even hydrogen peroxide also.
Yeah, yeah.
So we converted the reaction and we got the benefit of the rate of reaction, the unit size. Instead of 10 kiloliter reactor, we converted exactly into the only 10 liter
Mm-hmm.
in the continuous form.
Mm-hmm.
And moreover the labor also we have saved. How? Taking that reactions and taking into the distillation and again purify, instead of that continuously, because it is the hotspot reaction. So as soon as the reaction finish, we send into the small distillation unit and distillation online taking place, and we got the three benefit. One is the efficiency, another is the safety, and third is the controlling of exothermicity, which is
Mm-hmm.
more related to the hazard also.
Okay.
So this is the best example of the intensification process, the conversion of batch into the continuous.
Yeah, that is a great example, sir.
Yes.
Yeah, and that is what the Manish sir discussing about how they have converted the batch process into continuous, right? So let's say to be a technical graduate, we have to deal with different kind of design parameters or design considerations. Okay, so let us start with the very important discussion. What are the design considerations, right? because as an engineering graduate, we have to look for different aspects. So these are, let's say, this will be a bucket list for any engineer, that if you want to do a PI for your process, what should I do? Initially, I will go to the literature, I will go to the various examples set by the other industries, and I will try to put my perception about that. So, as we discussed earlier, either whether is the process is based on batch or continuous, right? So that is the next and very important as a chemical engineer, whether do this process is having any rate limiting step. It may be in terms of heat transfer, mass transfer, mixing, and so on, depending upon your process, right? Then if you are aware about ki, I have, let's say, n number of parameters, n number of equipments, which I have to intensify, but which kind of appropriate intensification tools I can use. So I can create my own modules. What will be the concepts I need to implement? Okay. So in some of the processes, as Dr. Manish has already said, the safety is of utmost importance. So can I reduce any kind of chemicals? Let's say you can eliminate the solvents. Okay. If we are using catalyst, how it is supported inside the system or how it is supported outside the system, how it is to be let's say packed inside the bed. So these are the different parameters related to the CRE. Next and very important, let's say if we have to discuss in terms of thermodynamics, can we reduce the pressure and temperature gradient? As Dr. Manish already discussed about the process intensification processes, one of the literature, it is mentioned that our system has intensified in terms of its space, process parameters, optimization, up to 100-fold, right? So this is all depends upon this, whether it is batch or continuous process. You are having different kind of tools, modules. You can either eliminate one of the reactant, you may have different kind of catalysts. Okay. And based on thermodynamics, whether you can reduce or control the pressure and temperature gradient. Okay. uh, there are different techniques, but
Sir,
as this is basic, we are not going in detail. Yes, sir. Do you want to add something?
sir, I want to highlight. Thank you,
Yeah,
sir.
please, please.
Uh, Again, I remember that solvent, eliminate solvent point. So in batch reactor, they used to take toluene,
Mm-hmm.
and the catalyst was sodium carbonate
Okay.
for the epoxidation reaction. But
Mm-hmm.
when we designed this pack bed, so
Mm-hmm.
we took the Lewis acid as the catalyst.
Okay.
It gives the very efficient rate of reaction,
Mm-hmm.
and we removed the toluene.
Okay.
So the it is helpful to reduce the energy as well.
Yeah,
In
definitely.
distillation, we have to remove the toluene,
Mm-hmm.
means lot of expenditure will be there.
Yeah.
First you have to give heat, and then condense, and then collection, everything. So
Mm-hmm.
solvent was not required. We removed the solvent, and just by sending two component
Mm-hmm.
to reactant and catalyst, that reaction happened with the more efficient way. So this is the very important part. When we took the design in intensification, we can remove the solvent. We try to remove the solvent if possible. Thank you,
Yeah,
sir.
definitely. Yeah. Apart from that, let's say how many number of stages we can have. So let's say sometimes what happens, though you will work on different criteria to have a multifunctional modules, there may be some loopholes, right? So how to rectify those, or how to identify those, how to troubleshoot those, right? And let's say how to enhance my transport rate. As a chemical engineer, we have to discuss about heat, mass, momentum transfer. So how to deal with all these parameters, and what are its, let's say, correlation with other parameters. So let's say if someone is saying that PI is necessary, as my personal view, yes, PI is very, very necessary, but it can be implemented only and only after a detailed study, detailed plan, and detailed blueprint. Otherwise, your system may fail. Okay, so these are the all design parameters which one can decide. As once again, I want to highlight, as we are discussing very basic things, these 6 to 7 design parameters may change, may vary as far as the different processes as concerned. Okay. Yeah. Next slide, sir. Yeah, this is very important, how to do the process integration. Okay, so I would request Manish sir, because as he is having expertise in the process integration, and he has worked in different industries where he, under his leadership only, there are some parameters he has changed. Okay, so as an expert, he can highlight this, but I would like to request to you, sir, just try to focus on only few points,
Sure.
as we are short of time.
Yes, sir. Thank you, sir. I would like to tell especially in the unit reduction, individual unit reduction, and then we connect those unit, and we when we make one process, so that process, whole process is called the integration. But basic is the intensification. So, and another point of integration is we have to recycle. Don't waste anything. For example, if you are using catalyst, you have to recycle catalyst in a such a way that it will be utilized. For example, I want to give shortly, in the paper industry, they are using the sodium hydroxide. And if you are not able to recycle that sodium hydroxide 20% solution for the cooking, it will be waste. You cannot throw, environment will affect, safety problem will be there, environment problem will be there. So better to make another process so that it will be recycled. And while recycle, you will get lot of energy. That energy you can use for the making of the electricity as well. So 50% of the electricity you can make in the paper industry with the help of these two things. वो कहते हैं ना कि एक तीर में दो पक्षी मारना. तो दो फायदे हैं. You will get the two things. One is the recycle and another is the energy efficiency. You will get the energy back. So this is called the integration process. It may applicable to multiple technology as well as the individual also. And in that way, you can improve the efficiency to reduce the capital cost as well as operating cost also. So integration is the next stage of the intensification. So how to achieve process integration? So you can achieve the process integration with the help of when separate people or things are brought together. When you bring the all small unit in the one unit, try to compact. If you have 10 units, try to reduce into 8 or try to reduce into 5. So you can say it will be integration. And it is exactly, you can reduce the size also, whole process size, with the help of integration, and it will give the lot of benefits. So when you use this integration process, you have to apply a lot of controls to get to do the integration, and you have to execute cross system process sequence. What can be done in sequence so that the process can be reduced? You have to monitor that process in such a way that you can reduce the size. Ritesh sir, and this is the best example of nowadays distillation column. There is a research is going on how to convert into the reactive distillation. So the combination of the reactions and distillation all together in a one place. Ritesh sir?
Definitely, this is one of the best example which already we have cited, where reaction and distillation, uh, it's combined into one section, so it can give a reactive distillation. Okay, actually a distillation itself, it is a big, let's say, industrial reactor where we can have different kind of reaction mechanism. And if we can combine that as a hybrid, as a process intensified method, yes, we will be benefited. And as sir suggested, a lot of research is going on, and already many of the industries has installed different reactive distillations. Apart from reactive distillation, there is one more part, let's say, for a dividing wall column, which is one of the PI equipment, which is published by AICHE. And if you are able to see on the our right side, that is conventional column system, where a combination of two reactors, then heat exchangers, then you are getting from somewhere, you are getting the product, either it may be pure, it may be impure, it depends. So what you want more energy resources, you want more space, you want more collecting hands, you want actual feed and its location. If you are aware about the design consideration of distillation, you can visualize and analyze the situation to work on a distillation. But if someone come with combining of these two columns, then what, there will be a dramatic change in a process. So one can get increased purity, so efficiency will increase, energy will be reduced, right? Space will be reduced. Okay, so there are different parameters which already discussed in the literature as far as dividing wall column is concerned. Yeah, next one, sir.
So as far as concerned with the system integration, we have to look after the physical and virtual. These are two aspects will be there for the integration. In physical, most of the hardware, computer hardware and inventories will be there. And if you see the virtual, you have to talk about the data storage software, utilization of software. You have to use the software to integrate the process. Ritesh sir?
Yeah, the integration of process, let's say we are going to show you some examples only, because if we'll discuss this may take a lot of time and we are shortage of time. So this is one example which covered from the Corning Industries, where they are working, they worked on a monolithic reactor, and they just tried to show you that monolithic reactor, these are reactor where we are having a low pressure drops, they can provide which kind of reaction system, reaction mechanism you have. But if you can combine that monolithic reactor with different kind of let's say reactors, and some heat and momentum and mass aspects, what it can be done. So let's say a pictorial view on the right side, if you are able to see that one tree, which is, let's say, it is not having any components, let's say. But when you started with this, on the left side, you will be able to see that the green tree. So let's say it is like that. When you are going for any PI, you are going to increase the efficiency of the system. Okay, so as far as the picture is concerned, we can have different kind of interpretation. So that is my own interpretation which I thought to share with you. Okay, the next one, you can go through the website of Corning for different PI methods. Next example, sir. Yeah, I will just try to in short time, I will just try to show you that if we want to reduce the size of plant, what we have to do, there are different parameters we can have. Let's say in the figure which we have kept on this slide, you will be able to see that different columns, those are standing in front of you along with piping, right? So what is our need right now? We don't have these many parameters or this many resources. So what we have to do, we have to combine all these things to reduce a lot of utilities. It may cover n number of parameters, right? So it will start from your basic physics or mathematics to the technology aspects, right? Yeah, next one, sir. Yes, so this is one
This is one of
example.
the. eh,
Yeah, yeah, please, please, please proceed.
Yeah, continue, sir. Continue. Continue, sir.
Yeah. So as I had discussed in the last slide that we have to reduce the size of reactor. You have to check its connections, right? So one of the example which we thought to discuss with you was oil drilling rigs. So when we will have a next, let's say a webinar, we'll try to discuss this in detail. Yeah, next one, sir. Next slide, please. Spinning disk reactor, it is also one of the
This one.
yeah, let us go for this. This is very important. This
Yes,
is
sir.
given by Eastman.
Yes,
Spinning,
yes.
sir, spinning we will try to discuss in the next webinar whenever we will have a time. We'll try to
Next
discuss
way.
this
Yes,
spinning.
sir. Yeah,
So
right.
we'll go for the yeah.
Right.
This is from Eastman Chemical. Interested students, interested participant can go to the website of Eastman Chemicals. See on the let's say left side, you will be able to see that the PID, which has shown the different kind of parameters, how the reactors are connected, and how we are getting the product. But what happens in the task integrated, which is on your extreme right side, that all these unit operation unit processes are combined in a single reactor, and your system now it is ready to work for, right? So this is what the integration of different processes is. Okay. Yeah, next one. Yeah, these are the references which we have cited in today's discussion. uh, and thank you very much everyone, those who are here to on their interest to study about or to discuss about process intensification. Please note that this is very vast subject. If Dr. Manish agree with me that this is not being covered within an hour or so, it will require so much time to understand the different aspects. But our aim is to highlight the different processes which can be intensified with the help of this technique. So, as an initiative taken by the Marwadi University, we thought to share our expertise. Okay, and if you are having any queries, you can raise your hand. And if anyone wants to give your suggestions, also it is always welcome. Apart from this, I feel sometime before we had, yeah, we have one of the participant, Abhijit Kulkarni. Abhijit, are you there? Abhijit?
Yeah, I'm here. Hi
Yeah.
Ritesh,
Good
how are you?
afternoon. Good afternoon, Abhijit. Actually, I just want to,
Yeah, I have.
yeah, I just want to,
Yeah,
uh, yeah, Abhijit is one of the entrepreneur. I know him as he worked with me. He's working on the same area itself. Abhijit, do you want to share some views based on it within a minute or so?
uh, sure. Of course, means I was about to raise my hand.
Yeah.
So before my sharing experience, I would like to ask Mr. Manish sir, actually
Yes, sir.
request. So
Yes.
can you just elaborate more about the software integration over this PI?
Software integration means, sir, if you are using Aspen and HYSYS, and if you are able to do the proper process, so
Mm-hmm.
it will give the accurate uh, design. If you take for example heat exchanger, and if you
Mm-hmm.
apply the Aspen, and if you are able to get the proper design of the heat exchanger, so you can say you are utilizing the software, and you are the accuracy towards 100. But
Mm-hmm.
if you do the trial and error, if you are not able to design the properly, then your approach will not be towards 100%. So
Okay.
you have to utilize the process, software process, to make the process is more and more accurate.
Okay. Thank you, sir.
Yeah.
Thank you, sir.
So,
Abhijit.
Ritesh,
Yeah,
yeah.
Abhijit.
So basically, as the sir has already told that they have scaled up their reaction in the while they were working in the industry. So basically, we also deals with the same kind of process and same
Mhm.
kind of industry, and we have almost converted so many batch reactors or batch data to the continuous. So reactions such as John's oxidation and epoxidation, so many reactions we have also converted to the continuous scale up. So basically what we deal with, we also deal with the process intensification, and
Yeah.
currently we are dealing with the micro reactors.
Yeah, yeah. In
So
addition to this,
we have also worked.
yeah,
Yeah.
yeah. In addition to this, I just want to inform our viewers and participants. Abhijit has worked with Corning, if I'm not wrong, right, Abhijit?
Yes.
Yeah.
Yes.
He worked with Corning Technology. Yep. Continue, Abhijit, please.
Yes. So my startup name is Florex, and we are also working on the distillation. So we have received a government grant for the continuous intensified distillation. So we are currently working on it on the similar basis. So that, as sir was saying, integration of all the technology. So currently we have our demo, we have our equipment for the micro reactor. So we are also working for the different processes like distillation and extraction.
Great, great,
So
great.
that we can integrate all the process technology. So from it's like start to end, everything like process downstreaming and process reaction.
Yeah,
Right.
fine, fine.
Exactly.
Yeah, thank you very much,
Yeah.
Abhijit, sharing your views. As he's one of the, let's say,
And
he's of your age only, those who are participants. Let's say, I want to keep your attention like this. He's one of the youngest entrepreneur to whom I personally know and who did his growth. Actually, he is from my friend circle when I was doing a PhD. And this is a group of 4 or 5 entrepreneurs, those who are working from last 4 to 5 years. And you cannot believe this, that these guys are very fabulous. They are working for government grants in, let's say, at the age of 25 and 26, these guys have grabbed so many funds, right, Abhijit?
yes, sir, yes, sir. And
Yeah,
thanks a lot for your this great initiative by the Marwadi University.
yeah,
It's
yeah,
really helpful during this lockdown period so that we can share thoughts with each other. Even I
yeah, yeah.
don't know the participant, mostly I feel they will be student,
Yes, yes,
but I can suggest them they are free to call anytime for if they have any queries. Even I would like to interact with you and even with your other faculty with the Marwadi University at any
definitely.
time.
Definitely, Abhijit. I will plan one session, let's say for 1 hour or so with the other students, like this webinar. So we will have a interactive session with you, like interview, right? I will communicate in for this
Sure,
purpose.
sure,
Okay. Yeah. Thank you, Abhijit.
sure.
Thank you, Abhijit. Yeah.
Yes, sir.
So
Thank
if
you.
Thanks a
Thank you,
lot.
sir.
yeah, yeah, welcome.
Thank you, Abhijit.
If someone if anyone is having any queries, doubts, they can write to us. If you want to discuss right now, please raise your hand if you want. Otherwise, we can stop here. Okay, I feel I take this opportunity to say thanks to everyone. Thanks to Professor Manish Khodwe to share his expertise along with me. To the students, as well as we are having some participants uh, from different states also, those who are participating in today's webinar. So I feel this is a kind of, let's say, little a donation from our side, let's say, sharing our knowledge which we are having. Still, I just want to add to this, we are also learning, right? So as we will share our thoughts with the others, we will be able to nourish ourselves also. Okay, so stay at home, stay safe, and keep learning. Thank you everyone for joining to us. And one more request, I just want to have the email IDs of all you guys who are present right now. So you can type your email IDs, proper email IDs, okay? Proper your email IDs, please try to put in the chat box so I can make the further announcements. Either in terms of certificates also, we are proceeding for this. So in due course of time, we will communicate with you. So all of you are requested to put your email IDs in chat box. Yeah, thank you very much. Thank you, Praveen sir. Yeah, one of the faculty who joined us from SGGS Nanded, Praveen Sonakar, Dr. Praveen Sonakar. Thank you, everyone, joining for this.
Thank you.
Yeah.
Hello. Sir.
हेलो यस
सर इसमें चैट बॉक्स ही नहीं दिखा रहा है
चैट बॉक्स पता नहीं
सर रितेश सर को मैसेज कर देते वो कर दे
हाँ, मैसेज करो ना, होस्ट को मैसेज आ रहा है वहाँ पे ना।
वो कहा सर हमने प्राइवेट में मैसेज कर दिया सर आपको
हाँ,
ईमेल आईडी
नहीं, जूम चैट बॉक्स में देखिए आ रहा होगा। चलो अभी चेक करो, प्लीज चेक इट नाउ।
सर आ रहा है, मैंने तो सेंड किया एट सेंड सर।
I want this in chat box only, so I can have that proof. Okay, please do not message me.
सर
Message me on my phone. You are requested to put your email IDs. Okay.
सर इसमें वो नहीं आ रहा, वो सिर्फ आपका पर्सनल में डॉक्टर रितेश पारकर होस्ट करके
नहीं
उसमें
सर
क्लिक
हो रहा
करते
है
हैं तभी आ
एवरीवन
रहा है।
करना है एवरीवन होगा एवरीवन करना क्या
बेटा उसी में करो अभी।
सर हो रहा है
हाँ, प्लीज एक्सप्लोर इट।
हाँ यस सर।
it's coming lot of email IDs are coming thank you for joining all of you
थैंक यू सर।
सर पालकर सर
Yes sir.
अभी कंटिन्यू करना है लीव करना है
For a minute or so, sir. Let them write their email IDs.
send yes I think finish
Yeah. Okay, fine.